Hey guys, so we're going over the homework that was assigned on Monday. So page 817, 1 through 27 odd. This was probably besides the first lesson, the first and last started easy, ended easy. I like it. Okay, so I have the page right here, I have it printed. Sorry, these are always hard to see, and thanks for not complaining and being good sports about it, those of you that have been doing it. So yeah. I appreciate that work ethic. You know, when teachers see that you're doing your work despite everything that's going on, and they see that work ethic and they see that you're not trying to take advantage and, you're actually working and you're not being lazy, like that really shows. Like that shows a lot of people that you are a hard worker and that you can handle pretty much anything that you tackle. So those of you that have been doing that, if you ever need a letter of recommendation, I will write you a good one. So definitely, keep up that good work. I'm proud of you guys that have been on top of things and getting things done. Even if it's a day or so late, that's no big deal. But those of you that have been working and have been communicating with me, you guys really show your true colors and that you can work really hard. And I do appreciate that. It's hard to find these days, especially in younger people. So anyways, I could talk about that for a while. Okay, so page 817, we are on the odds, so number 1. So it says, for 1 through 8, match the function with its graph using horizontal asymptotes as aids. For these, I also use the vertical asymptotes to help me out. And Mrs. Ardito kind of went over that a little bit in the notes. She didn't write down the vertical asymptotes, but she talked about reviewing how to find them because we did do that in first semester. And the graphs are labeled A, B, C, D, E, F, G, H. And you can see I kind of already marked up mine. So what I did, so it helps when you have it printed, because obviously if you don't print it and you're looking at it on the screen, you can't mark it up. But I can tell, like this graph right here, and maybe I should use a light colored marker. So give me just a second. I like this green one. I see that these graphs are kind of doing this thing here. They're approaching this vertical line. So I see a vertical asymptote here. And I also see, obviously, the very obvious one, the dashed horizontal line here. So there's our horizontal line, okay? So I liked going through the graphs first so I could see what the heck is going on before I look at the functions. In letter B, I see that these are kind of hugging this wall right here, that vertical asymptote. And then obviously we see the dashed line on the x-axis. There's our horizontal asymptote. Then in letter C, I see this vertical asymptote and this horizontal asymptote kind of up on the horizontal is up further to the positive y. I see this number, I think it's a 5 or 6. Okay, so this is close to 5 or 6, whatever that number is. You didn't have to know exactly. This one has a vertical right here and a horizontal up here. Okay, and letter E has a lot going on. It has 2 vertical asymptotes, one right here and one right here. So I see this little parabola looking thing. And then there's, oops, gotta switch colors. And then there's a horizontal right here, okay? And so this line, this solid line, that's the x-axis. So this dashed pink line that I drew in here, that means it's below the x-axis, which means it's y equals a negative number. And there's a -9 down here, so it's not super close to the -9, so it's probably like a -2 or 3 or whatever, okay? It's definitely bigger than 1 though, because it's got that big old chunk below the x-axis. All right, letter F, I see also 2 vertical asymptotes around that parabola looking thing. And I see this horizontal asymptote, okay? This one, the horizontal is above the x-axis, so it's at y equals probably a +1, maybe a 2. No, it's probably 1 because that says 4, so that's probably a 1 if I were to guesstimate there. And then letter G, I see, I made it crooked here, but there's probably a vertical asymptote right about here. The first time I attempted that, it was crooked, so I messed up a little bit. And then I see, obviously, the horizontal there. And then last but not least, I see letter H. There's a vertical asymptote where these 2 graphs are hugging the wall there. And we have the horizontal. And this horizontal is also below the x-axis, so it means it's y equals a negative number, probably a -1 or -2, something to that extent. Okay, so we've gone through each of the graphs. Now we have to figure out, well, which one goes where? All right, so obviously you need to do this on a separate piece of paper. If you printed it out, you could fit the work on here. It's just so crammed. It looks so much neater when you do it on a separate piece of paper. So, I mean, I know some of you guys are like, I don't want to waste paper, or you use that as an excuse to be a little lazy, which is okay. Been there, done that. But it looks so much cleaner on a separate sheet of paper, guys. All right, so number one I see is f of x equals 4x squared over x squared plus 1. And what we got to do is we have to look at the end behavior. So that means we have to look at where the asymptotes are. And I want to focus on, obviously, the degrees. Like Mrs. Ardito said, we have to look at the degree of the numerator versus the degree of the denominator. And both degrees are the same. So when they are the same, that's where you take the leading coefficient over the leading coefficient. So the leading coefficient of the numerator over the leading coefficient of the denominator. The leading coefficient of the numerator is a 4, of the denominator is invisible, as Mrs. Ardito calls it. It's a 1, and so it's basically 4 over 1, which is just 4. Okay, so that's number one, number uno. Okay, number 3 is, sorry, I'm trying to get situated here. Oh wait, I didn't pick what graph. So we know it's a 4. So that means, okay, so y equals 4. I'm thinking I'm finding the limits. I totally forgot. All right, so that means I know that I have a horizontal asymptote, HA. Remember I used to label them HA and VA? HA for horizontal asymptote, VA for vertical asymptote. Well, okay, so we found the HA. Now for the VA, we look at the denominator and we're looking for what would make the denominator 0, okay, the restrictions. So if I factored x squared plus 1, I can't because it is not factorable, okay? So whatever x is, positive or negative or 0, there's still going to be, if it's 0, there's a 1. If I plug in a -1 squared is 1, 1 plus 1 is 2. So it's always going to be a positive number because even if you square a negative number, it's still going to be positive. So there is no vertical asymptote. There's no restrictions of the denominator. So there's, yeah, okay. So when we look at number 1, I need to decide which graph it's going to be, okay? And I'm basically going to look at where possibly a horizontal asymptote would be y equals 4. So I'm like, okay, this one says the high is a 3, so it can't be A. This one's on the x-axis, so it's not B. This one, if this number, I think it's a 6, it looks like a 6, that one could be it, okay? This one could be it. This one, the y equals a number, this is below the x-axis, so that's negative, so it's not E. This one looks like it's probably a 1, and it had 2 vertical asymptotes, and we know that it didn't have those, so it's not F. This one, it has a vertical asymptote at x equals 1, so we know it's not that. And here it's saying this one's in the negative, so it's not H. So it's got to be C or D, so it's got to be one of these. So I think C would probably be the closest. Yeah, just because it has a little bit of some lower numbers going on there. But I mean, I could see if you picked D, it's really close, okay? Another way to check is to use Desmos and go ahead and actually plot that. Put y equals, because you can't put f of x in Desmos, y equals 4x squared over x squared plus 1, and you'll see. Okay, so if you ever get stuck it's down between 2 graphs, I would go to Desmos next and verify from there. But I'm going to pick C with this one, and if I need to go back and change it based on the other ones that I do, you can always do that, because sometimes you have to do that. It's a process of elimination, and we're just learning these, so we're going to start looking for more and more clues as we go, or we're going to remember more and more clues as we go. All right, number 3 is f of x equals 4 minus 1 over x squared. okay? So for this one, I notice a couple of things. I notice, well, first of all, I don't just have one fraction. I have a 4 and then minus a fraction, okay? So that can be a bit of an issue there. But let's remember some things. First of all, let's look at the degree of just if it were f of x equals 4. So if I had an x there, that means that its degree must have been 0, because that's how that would go away, which means that the denominator would have a degree of 0. Okay, Lucas, are you done?
No, I can't do my CGI problem.
You can go in your room and do it.
No, I can't figure it out.
Okay, I'll help you in a second, okay? Why don't you take a break? And why are your shorts hanging around your ankles? Oh my gosh, I'm so sorry, guys. All right, so anyways, if I just look at that, the degrees are obviously both a 0. So when the degrees are the same, it's the leading coefficient, right? So which of the top over the bottom, so it would be a 4 over 1, which is just a 4. Now let's look at this term separately, the negative 1 over x squared. Well, the degree in the denominator is a 2. There's no x in the numerator, which means that the degree was 0. So that means that it's got a big bottom, as Mrs. Ardito said. Big bottom. So someone's sitting on it, so it is at a y equals 0, the x-axis, okay? So look at this. That means I have a limit of 4 minus a limit of 0. 4 minus 0 overall is 4, okay? Another way that you could do this is you can get common denominators and then combine them and then do the work, and you're still going to get 4. Takes a little bit longer. In fact, that's how I did it the first time because I didn't think about separating it like that, but it works to separate it. Okay, so this one has the same horizontal asymptote as the first one. And in the denominator, the only thing that would make this not true is if the x squared is 0. Okay, so, and actually that makes me think of, I might have been wrong when I said that there's no vertical asymptote in the first one. Because if you set x squared plus 1 equals 0 to 0, you subtract 1, and you take the square root on both sides, you're going to get x equals plus or minus I, an imaginary number. Okay, so there is an asymptote in there. It's just we don't normally see that because it's an imaginary number. Okay, but for this one, we know for sure if we plug in a 0, it makes the denominator undefined. Okay, all right, so that means you know how these were between C and D? One of these is C and one of these is D. And so this one is actually D. Okay. But like I said earlier, if you mix these two up, that's no big deal because they were pretty much, I mean, look at them. This one just has a steeper curve than this one does. This one has a shallower curve. It's more squished. Okay. So yeah. Alrighty. So on to number 5, and I think, because I want to try to save some space, I'm going to put 5 over here. Sorry about Lucas interrupting me, but this is what happens when you're trying to teach from home and you get distracted and you have to multitask a lot. And yeah, so, and he's having trouble with his math problem today. He gets so mad when he can't figure it out, and I'm trying to tell him you just have to work hard, but he gets really upset because math is easy for him, and when it gets hard, he just wants to give up. And I'm trying to teach him not to do that he needs to persevere. And that goes for all of you guys too. Some of you guys, when it gets hard, you just want to give up. All right, this one's actually not bad at all. I see that the degrees are the same. So that means we have to take the leading coefficient of the top, which is a 1, over the leading coefficient of the bottom, which is also a 1. So that means that our HA, the horizontal asymptote, is y equals 1. 1 divided by 1 is 1. Okay. And let's also take a look at the vertical asymptotes. If I were to factor x squared minus 1, I can factor this because it's a difference of 2 perfect squares. Factors down to x plus 1, x minus 1. So that means I have vertical asymptotes. If I were to solve x plus 1 equals 0 and x minus 1 equals 0, I would get x equals -1, x equals +1, right? So that means that x equals plus or minus 1, to write it a short way, are the vertical asymptotes. So that means I have a vertical barrier at x equals 1 and another vertical barrier at x equals -1. So it has two vertical asymptotes. And it has a horizontal at y equals 1. So let's take a look. This one doesn't have two vertical. No, no, no. This one has two vertical, and this one has two vertical. So we got to figure out which one is it. Okay, well, the horizontal asymptote is y equals 1. So this one has a horizontal below the x-axis, so that would be y equals a negative number. So it's not E. This one has one that looks like it's at y equals 1 and the two verticals, so it's got to be F. Okay, using our clues. Blues Clues. You guys remember that cartoon? I remember my younger siblings, oops, wrong 7. My younger siblings used to watch that all the time. And then because they're watching it, you kind of get stuck having to watch it. That and Dora the Explorer. Oh, the worst though was Barney. Do you guys remember Barney? Do you even know what Barney was? Oh, there was a song at the end that he sung every time, and it just gets in your head, and then you're mad because you're like, I can't get it out of my head. But anyways, okay. So for this one, it's kind of out of order. So if you're okay with looking at it this way and realizing what the degrees are in the numerator and the denominator, then that's fine. Leave it that way. If you have trouble, then reorder it. Put it in standard form. So the -2x would go first and then +1. So some of you might need to do that because you're a visual person and you need to see it the way you want to, look at it in your head, okay? Or process it in your head. All right, so the degree of the numerator is a 1. The degree of the denominator is a 1. So again, the degrees are the same, which means we take the leading coefficient of the numerator over the leading coefficient of the denominator. So for our HA, it would be y equals, if a -2 is my lead of the numerator and 1 is the lead of the denominator. So -2 over 1. Okay, so that means that we're at a horizontal asymptote of y equals -2. All right, so the graphs that have negative asymptotes are not A, that one's positive. This one's on the x-axis. That one's positive, and we already used those. E is negative, and H is negative. So it's got to be E or H. Okay, E has two vertical asymptotes, H has one. All right, so let's look at our vertical asymptotes, the VAs. Well, look at the denominator, x minus 2. If I set this equal to 0 and solve for x equals 2 would be the answer. So that means I have a vertical asymptote at x equals 2. So this is just one vertical asymptote. And let's see, E has 2 and the negative horizontal. H has the 1, and it looks like that probably is a 2 because this is 12. So these dash marks are close together because this number is so big. Okay, so it's got the negative horizontal and the vertical. So it's got to be H. Number 7 is H. Okay, number 9. Sorry if I talk too much, but I miss you guys, and people are teachers for a reason, and I love what I do. I love being in the classroom with you guys and talking and making my corny jokes, and I'm really missing it right now. I feel like we just got gypped, and so I apologize for being wordy and telling stories and being silly, but I miss you guys, and hopefully my videos can put a smile on your face. I really hope so. I don't want to stress you guys out, even though some of you hate math and it stresses you out. But I really hope that you enjoy it. If you're in Enhanced 3, you got to be enjoying this at some point. Like polynomial long division, come on. You guys know you liked that. And these are fun. I like the limits. I love this. But anyways, okay, number 9. So we're out of the graphing part. Now, for these, it says find the limit if it exists. If the limit does not exist, explain why. So your work is going to do that explaining. So it's important that you guys have shown your work. I do dock points for no work shown, so please make sure you show your work. You guys know that. And it says use a graphing utility to verify your result graphically. So if you're ever not sure go to Desmos and type in these functions. It would be y equals 3 over x squared or y equals 5 over 2x and see what it looks like. And it doesn't exactly put the asymptotes on there, but you can tell where the graph is approaching and where they would be. Okay, so you can always use Desmos, a good resource. All right, so let's take a look at this. I'm looking at the denominator because that's popping out at me. And I see that the degree is a 2. There's no x's in the numerator, so that means the degree is 0. So the degree of the denominator is bigger. So we got a big bottom. Big bottom. Okay, so that means that someone is sitting on the x-axis, so the HA is 0. So that means the limit is 0. Because the limit always has to do with what it approaches on the y. Okay, so equals 0 is the limit on number 9, and how easy was that? So the work you're showing is you're identifying what the degrees are, and then you're saying, you know, what we learned in the notes, even though it's just pertaining to us. Every teacher teaches these differently, but Mrs. Ardito and I are saying big bottom. So that's how you tell me you know what you're doing. That's how I know that you know. Little Friends humor for those of you that watch Friends. All right, number 11, the limit as x approaches infinity of 3 plus x over 3 minus x. Okay, all right, so again, these are out of order, so if that bothers you, you can totally reorder it and put it in standard form. That might help some of you when you're getting used to looking for the leading coefficients, because in this particular problem, we will be looking for leading coefficients because the degree of the numerator is a 1, the degree of the denominator is a 1, so they have the same degree. Okay, so actually I won't rewrite it this time because I did it on the last problem. I want you to get to the point where you can recognize that. So, all right, the coefficient, the leading coefficient is the coefficient on the term with the highest degree. Well, the highest degree in the numerator is to the first power, so its coefficient is the 1. In the denominator, the highest degree was a 1, and its coefficient is a -1. So the limit is the leading coefficient over leading coefficient, which is 1 over -1, which is -1. Okay? Like I said, you could rewrite that. So if you rewrote it, it would be x plus 3 in standard form, and in the denominator, -x plus 3. Totally up to you if you want to do that. Okay. The limit as x approaches -infinity of 5x minus 2 over 6x plus 1. All right, so for this one, let's see here. Again, the degree of the numerator is a 1, degree of the denominator is a 1. They have the same degree. So this is where we take the leading coefficient over leading coefficient. The leading coefficients are these numbers right here. So it is 5, 6. Aren't these so easy, guys? So easy. I hope you're enjoying the easiness of this. And if it's not easy, you need to come on my Zooms and ask me questions so I could explain things to you. 2 minus x squared. Okay, so again, this one, the denominator is out of order. It should go in standard form, -x squared plus 2. So if you need to rewrite that, do it. I'm not, because we're going to try to just be able to recognize some things. So, because I do want you to be able to get to that point. All right, what color am I on? I think I wanted to use orange. Okay, so the highest degree in the numerator is this 2, and the highest degree in the denominator is also a 2, so again, they're the same, okay? The leading coefficient of the numerator is a 4. The leading coefficient of the denominator is a -1. Well, 4 divided by -1 is -4. So the limit for number 15 is -4. 17. We got the limit as t approaches infinity of t squared over t plus 3. Okay, so for this one, I'm seeing the degree of the numerator is a 2. The degree of the denominator is a 1. Okay, this time it's got a bigger top. Okay, so big top. So that means Buzz Lightyear, infinity and beyond. So since it's going to infinity, the limit does not exist. DNE. Number 19, the limit as t approaches infinity of 4t squared plus 3t minus 1 over 3t squared plus 2t minus 5. Okay. Yeah, that looks big, but it's not scary at all. You're just looking for the degrees. So the degree of the numerator is 2, the degree of the denominator is 2, so the degrees are the same. So we're gonna have leading coefficient over leading coefficient. They are 4 and 3, so the limit is 4/3. I'm gonna flip this over to the other side, 'cause I'm out of room now. And I'm on 21. Number 21 is the limit as y goes to plus or minus infinity. It put the plus and the minus next to each other, but I think it looks so much better when you put plus over minus. But that's up to you if you want, however you want to write it. And then it's 3 plus 8y minus 4y squared over 3 minus y minus 2y squared. Okay, so this one's out of order, but again, we're gonna get to the point where we can recognize, you know, the highest degree, and that being the leading term, okay? So the highest degree in the numerator is 2. The highest degree in the denominator is 2. And so the leading coefficients, because the degrees are the same, leading coefficients are what we have to look at next, and so the number in front of that degree term is a -4 and a -2. So those are my leading coefficients, even though this is out of order, but you could rewrite it and put it in standard form order. All right, so -4 over -2. -4 divided by -2 is +2. So the limit on 21 is 2. Okay. 23 is the limit as x approaches negative infinity of negative x squared plus 3 over 2 minus x quantity squared. Okay. All right, so there's a couple of things here. There's so much going on, it would be hard to do this in our heads and not make a mistake. So what we got to do is kind of simplify this out a little bit so we can see, okay, what really is the degree? What's the leading coefficient? So let's go ahead and rewrite this and distribute that negative. And also 2 minus x quantity squared means I have 2 minus x times 2 minus x. Okay? So I'm just going to rewrite this. Limit as x goes to negative infinity of, let's see, in the numerator, I'm going to have negative x squared minus 3. In the denominator, I'm going to have, I'm just going to try to put this in my head. 2 times 2 is 4, minus 2x, so that would be minus 4x, plus, because negative times negative is positive, x squared. So it's going to be x squared minus 4x plus 4. Okay, I just did that in my head. If you need to write it out, write it out. Okay, so now I can see the degrees easier and the coefficients easier. I see that the degrees are both 2, so they're both the same. And that means we take the leading coefficient of the top over the leading coefficient of the bottom. The numerator's leading coefficient is -1. The denominator's is +1. So that would be -1 over 1, which equals -1. So that is the limit on 23. So that one we had to put a little elbow grease into, but still no big deal. 25. So number 25, I have the limit as x approaches negative infinity of, and it uses a square bracket, x over x plus 1 quantity squared minus 4. There's a couple ways to go about this because we are going to need to clean this up a little bit. We can find the limit of the x over x plus 1 squared, and then the limit of the 4, and then subtract them. Or we could put the 4 over 1, get a common denominator, and get it to be one fraction, and then do what we've been doing. Find the degrees, see what they are, and then determine what the horizontal asymptote will be, and what the limit would be. So I think it's easier to just find the limit of this one, and then the limit of this one, and then subtract. Okay, so that's what I'm going to do. So if I'm looking at just the x over x plus 1 quantity squared, first of all, when we multiply this out, it'll be, because it's x plus 1, so that would be x squared plus 1x, so that'll be plus 2x plus 1. Okay, just like the x plus h times x plus h, okay. Except there's no h, so it would just be a 2x and then a 1, because there's no h, okay. Anyways, so I see just for this one that the degree of the numerator is a 1. The degree of the denominator is a 2. The denominator is bigger, so it's got a big bottom. Big bottom. Okay, and so that means that its horizontal asymptote is y equals 0. So the limit of just this is 0. So I'm going to put equals 0 minus. Now let's find the limit of the 4. So if I think about it, there's no x's on the 4. So that means that there is an x to the 0 in the numerator and an x to the 0 in the denominator, because anything to the 0 power turns into a 1. Okay, so that tells me the degrees are the same. And when the degrees are the same, you take the leading coefficient of the top over the leading coefficient of the bottom. So I basically have a -4 over 1, which is just a -4. So, and the negative is from that minus sign. So I already have the negative here. So -4, 0 minus 4 is -4. Okay? All right, so that was 25. On to 27. 27, we're going to handle a very similar way. It's the limit as t approaches infinity of the quantity 1 over 3t squared minus 5t over t plus 2. Okay, and because it's not just one fraction, we can do it in pieces. We could find the limit of this minus the limit of this, and that's just like what we did in number 25. So that's what we're going to do. Okay, so first of all, the degree of the numerator on just the 1 over 3t squared, because there's no x, that means there was an x to the 0 because it turned into a 1. So the degree of the top is 0. The degree of the bottom is 2. The bottom is bigger, so we got a big bottom. So when we have a big bottom, that means that the limit would be 0. Okay, so I'm going to put equals 0. For this one, I see the numerator degree is a 1. The denominator degree is a 1. So that means their degrees are the same. So we look at the leading coefficients. In the top, I have a -5. In the bottom, it's just a 1. So -5 over 1 is just a -5, so -5. 0 minus 5 is -5. How easy is that, you guys? All right, sorry this video was longer than I had hoped because it's just going over the homework. But I wanted to make sure I explained everything. Sorry I was kind of like all over the place at the beginning. My kids distract me, like I said. And I miss you guys. I hope you're doing well. Take care of yourselves. If you ever need me for non-math related things, or if you just want to talk, just let me know and we'll do a Zoom and we'll, you know, invite the class and talk to our friends or see people that we haven't seen in a while if you haven't seen anyone. And, you know, go from there because we need that too. We need that social aspect. So anyways, have a good one, and I'll see you guys in my next video. Bye.